I'm recording, by the way. And so make sure, this is our last unit. This is trig. It's our biggest unit, as you can see by how thick that packet is. It's going to take us a little bit into quarter 4, and then we have just review leading up to the AP exam on May 15th. Okay. So let's get started. Let me read to you. We're starting out with periodic phenomena, which is plural for phenomenon. A periodic function is any function that repeats its values on regular intervals or periods. Okay? So think about your breathing, your heartbeat, or the waves in the ocean. These phenomena repeat the same activity at a steady pattern. Breathe in, breathe out. That's one period. Breathe in, breathe out. Okay? The same repetition. The most famous periodic functions are the trigonometric functions. We will see sine, cosine, and tangent in our second lesson. Other examples of periodic functions in nature include light waves, sound waves, and phases of the moon. Okay? So today and tomorrow, just kind of general, what is a periodic function or phenomena, and then we go into specific ones when we get to section 2. Whatever we call it. All right, so let's go through some vocabulary. What? Periodic function, any function that repeats a pattern of y values at regular intervals. So we're going to be identifying yes or no, is it periodic, using that criteria. Cycle and period are the next two, and you're going to see they kind of get interchanged after we talk about it here. They're really interchangeable. So cycle is one complete pattern of the y values. Like I said, breathe in, breathe out. That's one cycle. On a graph, it's called a period. The horizontal length of one cycle for a periodic or repeating function. So for the period, I like to say how many units of the x value, of the x graph, of the graph is used to make one cycle. And I'll explain that better when we get to an example. And then amplitude is half the difference between the max and the min values of the function. And we have a formula for that. So it's half of the absolute value of the difference between the max and the min. So let me just explain that. When you multiply something by 1/2, you're dividing it by 2. So it's just like the average distance. So you take the max and the min, you subtract them. The absolute value symbol means it's positive. Why? Because it's distance. You can't have a negative distance. So that's what it means. And then you divide it by 2, and that gives you your amplitude. Okay? So let's look at an example here of a periodic function. You can see it's just repeating. If we start all the way left, it's on the x-axis. It goes up to 1, x-axis down to -1, and then back up to 0. So I will highlight for you one complete period. You always end at the same place you start, okay? You're never going to start at 0 and end down at -1. You always have to completely end up where you were before. That is one cycle, or period, you could also call it. But let's go a little deeper with period and say how many pieces, how many units of the x-axis are we using? And it's, whoops, I'm on the wrong notes. And it's approximately, I don't want to say that it's 6. It's approximately 6, but let's just say approximately 6, right? It's a little bit further. Notice it's positive. Distance is always going to be positive. You don't drive -5 miles. So no matter what, period is positive. And then we can talk about the amplitude is the min and the max, right, are 1 and -1. So if I find the difference between them, and it really doesn't matter what order you put them in, you'd get 2, and half of 2 is 1. So our amplitude is 1. And that's easy. You don't even need a formula if it's going up and down. If your min and max are the same number, like 5 and -5, that is your amplitude. Okay? But you're going to start seeing where it doesn't always work like that. The whole graph could be moved up or down, and that's where the formula comes in. All right, So in our first example, we're identifying a cycle two different ways. A cycle two different ways. So you kind of have to figure out where you want to start, and that's negotiable. We could all have lots of different answers here. So I like to start at 0 because I'm boring and it's easy, all right? So if I start at 0 and I complete one pattern, I'm in the middle, I'm going up, then I come back down, I go back through the middle, I go down to my minimum, and I end up again where I started. That is an example of a cycle. How much did I use of the x-axis? 4 units. So my period is 4. One cycle could be from 0 to 4. Or you could put it in brackets and use interval notation, which we'll start seeing me do. But from 0 to 4, that is an example. I shouldn't have gone all the way out there. To there. 0 to 4 is a period. What's another one? Let's start somewhere else. Let me use a highlighter this time. If I start, let's start at this point right here. If I start at the max, go through the x-axis down to my min, remember I have to end up where I started. That's another example of a cycle or period. We have one from -3 to 1. How many units is that? 1 to here's 1, 2, 3, 4. So where I highlighted in pink, it's still a period of 4. It's just starting at a different point. So you can see I even have a different shape there. It almost looks like a V versus like a blah, blah, blah. You know what that is? But I started and ended at the same place. I used the exact same.
Teachers and students, please pardon this interruption. General reminder, seniors, this message is for our seniors. The FAFSA information night does begin tonight at 5:30. That's here at Countryside High School, 5:30 in the Media Center. So any students that are planning to attend any institution next year for applying for any scholarships, please attend that FAFSA evening tonight, 5:30 p.m. in the Media Center. Also, today is the 23rd. Happy birthday, Coach Pusateri. Coach P, we hope you have a great day today. Make this a fabulous birthday. Sorry for this interruption. Happy birthday, Mr. P. Have a good day.
Okay, so understand the 2 cycles I chose are just 2 of lots of different examples, okay? So when you do these on the homework, I listed 4 of them and you have to have 2, so I just listed 4 that I see. But if you're unsure if your answer is good or not, let me know and I'll check it for you, okay? Let's look at another one, all right? Again, let's pick a starting point. Pick a starting point. Doesn't matter. I like to start at 0. So if I start at x is 0 and I go a full, complete the pattern and end up where I started, that right there would be 1 period. How much of the x-axis did I use? From 0 to 3. That means my period is 3. From 0 to 3. I could do a different one. I could use start this as my starting point. I started and ended at the same exact place. It's still a period of 3. I'm using 1, 2, 3, right? From here to here of the x-axis. That's my period. It's a different cycle. It's from, is that -4? -4 to -1. Okay, so these are just examples of any cycle. As long as you start and end at the same place and you use 3 units of the x-axis, that is considered a period. It just repeats over and over. Right? Look at my red. Start here, go up, but down. Then I could do it again. I could start here, go up, go down. Or if I was doing the blue pattern, here to here to here, it would repeat going on and on. Right? Page. Now we're saying yes or no, it is or it isn't periodic, and if it is, what is 1 period? How much of the x-axis are we using, basically? So is this first example periodic? No, Jacob, you're right, because the y values are not repeating. It looks like the X values are. I'm not going to spend time looking at it. Like it's using the same piece of the X-axis each time. But the Y values are not repeating at regular intervals. So this one is not periodic. I think you guys would agree that this one is periodic, right? And what would the period be? Just depends. The period doesn't change no matter where you start, but an easy way to start is to start at 0. So X is 0. I need to end up where I started, right there. So from 0 to 4 means my period is 4. How many units of the X-axis did we use to complete one cycle? 4. Doing okay? All right, here's where we get to use our formula. Find the amplitude of each function. You'll notice we have a max of 1, that's as high as it goes, and a min of -2. Since they're different, like if it was up 2 to down to -2, that's your amplitude. It's 2. Add those together, divide by 2, you get 2. So, but in this case, they're different. So we'll use our formula. 1/2 of my max minus my min. In absolute value symbols, because when I add those together, it's going to be +3 or -3, depending on the order I did it in, but we always want the absolute value of it. Distance is positive. Okay? And so 1/2 of 3 is 1.5. That is your amplitude. Know that formula. This one has several maxes, but we want the absolute or global max. So the highest place it goes to is 4, and the lowest is, I think that's -2. So the amplitude would be 1/2 of the max minus the min, which of course makes that 6. 1/2 of 6 is 3. Amplitude of 3. Okay. Sound waves are produced by periodic changes in air pressure. Sketch the graph of a sound wave with a period of 0.004 seconds and an amplitude of 2. So if you notice, all these graphs are written as regular old boring rectangular coordinate plane. X-axis, Y-axis, we're just zoomed in basically into the X-axis. So this is counting by normal old 1, 2, 3, 4, 5, 6, 7, 8, and so on. If the period is 0.004, we have to change what the X-axis is labeled as, or we can just write a little note. Let the X-axis scale, or interval you could say, represent, since it's going out 3 decimal places, I'm just going to call it 0.001, 0.002, 0.003. So 0.004 would be right here. So from 0 to 4 on my X-axis is going to be 1 period. Okay, and now you don't know what sound waves look like. I'm going to show you that, and then there's one in the homework just like this. And let's talk about the amplitude though first. So if the amplitude is 2, the easiest way to do it is go up 2, down -2. Could I go, up 3 and down to -1? As long as there's 4 units of the y-axis from the top to the bottom, that's all that matters, right? Up 2, down 2. Okay, so, but that's the easiest, so just make them the same if you get to draw your own. Here's what a sound wave looks like. You start in the middle, and then you go up to your max, to the middle, down to your min, back where we started. So you're going to learn on Thursday that this is actually the graph of sine, S-I-N-E, but it also matches a sound wave. So notice we always start and end at the same place, and now you know what a sound wave looks like. So that's 1 If it said graph 2 periods, we would do another one. Middle, up, middle, down, middle. So there would be another period. So what I have graphed right now is 2 cycles or 2 periods of this graph. Red is one, blue is another. Okay? That's the shape of a sound wave. Okay? Moving on. Okay, so we're going to do a word problem about pedaling the bike, and we're going to do one with, you're going to see lots of bike pedals in this unit and Ferris wheels. They love Ferris wheel questions. So let me read. Consider how the pedals on a bicycle rotate as the bike is being ridden. The height of a bicycle pedal varies periodically as a function of time. The maximum height is 18 and the minimum is 6 inches. So think about it. You're sitting on your bike, your foot is up, your left foot's the picture, your right foot up, your left foot's down, and you're 18 inches off the ground. And then you start pedaling, and throughout this pieces of a second, you're at 15, 12, 9, and 6 is when your foot is completely at the bottom, and then it repeats going back up. So it takes us 1 second to go from the top of the pedal down, and then we go back up, 9, 12, 15, all the way back up to 18 inches off the ground. So you can kind of picture if you're going to get a Ferris wheel question, like it's like at the top of the Ferris wheel, the bottom, and then back up again. What would the period be? What's the period of this function? We haven't graphed it. So 1, it would be 2. We have to get back to where we started, right? We started at 18 inches off the ground, got down to 6, and then back up to 18. How much time did it take? 2 seconds. 2 seconds to make 1 revolution. So x is your time, height is y. What would the amplitude be? Well, we have a formula for that. The max, it even told us in the problem, was 18 minus the min is 6. That equals 12. Half of 12 is 6. And it's telling us to graph the first 5 seconds. Let's just graph like 1 second. We don't need to graph all those points. So at 0 seconds, my height off the ground is 18, and so on. Just graph a few. You don't need to graph all of them. This would take me an hour because I can't see. I'll show you what's completed. So you can see at 2 seconds, started here, ended here. There is what it would look like on a graph, that revolution of your foot around 1 time. Okay, so don't worry about graphing movement. That's just busy work at this point. But I do want you guys to see something that I drew in here called the midline. So mid means middle. Line, I think we know what a line is. And if you notice, it's at 12. The relevancy of 12 is that there's 6 units above it, 6 units below it. So 12 is right in the middle of our max and our min. Kind of makes sense. So it's 6 up, 6 down. And that would be called the midline. Okay. All right. Last question. And I was confused with this at first. They're not related questions. It's just 3 separate questions. Okay. So answer each of the following. So a periodic function goes through 5 complete cycles in 4 minutes. What is the period in seconds? Okay. So quick glance. I don't know if you guys remember, like back in, I don't know, elementary, middle school, when you had to make little charts and you made all these conversions. We don't need to do that. It's super, super easy. My answer needs to be in seconds. What's given is in minutes. Let's change 4 minutes to seconds. What am I going to multiply 4 by? 60. So there's 240 seconds in 4 minutes. So what we're going to do is divide 240 by 5, and that will tell us how long it takes to do one cycle. 240 divided by 5, 48? 48 seconds. So one cycle for 48 seconds. The second cycle would take 48 seconds, and a third, and then a fourth, and a fifth. That would be a total of 240 seconds. Okay, the period, okay, so now they're giving us the period is 8 seconds. How many cycles do we go through in 30 seconds? Does it matter which number is on top when I divide? Yeah, think about what it's asking. We want to take our 30 seconds and divide it into how many cycles we can get. So it takes 8 seconds to do one. How many can we get done in 30? 3.75. Thank you. That would be 3.75 cycles. Right, think about this one. The amplitude is given, 2.5, and they give us the minimum, is 0. What is the function's max? It is 5. Good. So we're at 0 is our min. We're trying to find the max, and they give us an amplitude of 2.5. And so the 2.5 in this case, because we started at 0, is our midline. So from 0 to 2.5, and then 2.5 to 5. So the max is 5. Okay, so homework. Find it. Do you have the assignment written down already?